This tutorial is going to cover the mole concept as well as how moles relate to atoms and molecules. Now the mole is simply the SI unit for the amount of a substance present. So it's just a unit value. Just as we say 1 dozen, which represents 12, 1 dozen eggs, 1 dozen carts, 1 dozen cars, all of the different substances that can be represented by the term dozen always refer to 12 of those units. And so the mole here can represent that unit for us as well. Mole, of course, is abbreviated MOL, and a mole represents to us, again, a unit value. And a mole, of course, is specific for each substance. For example, we could say 1 mole of an element or 1 mole of a compound. And typically, how moles are used in chemistry is to relate them to a mass in grams, to the number of molecules, or to the number of atoms. So 3 different things, and we're going to discuss each one of those things in this tutorial. We'll start off with mass. How can 1 mole tell us how much mass of a substance we have? Meaning, what is the equivalent or conversion factor for 1 mole of an element? Well, 1 mole of an element is equivalent to its atomic mass. Let's say we have 1 unit of carbon, 1 mole, 1 carbon. How much in mass would that be? That would be in 12 AMUs or grams of carbon. 1 mole of hydrogen would be 1 AMU or gram. You could say 1 mole of aluminum, it would be the atomic mass of aluminum, and so on and so forth. Now, for a compound, which of course is 2 or more elements chemically combined, the equivalency is every 1 mole of a compound equals the molecular weight of the compound, or the formula weight. So the mass of the entire compound is equal to 1 unit of that compound. So, in the example of 1 mole of glucose, which is C6H12O6, if you took the mass of 6 carbons, 12 hydrogens, 6 oxygens, and add them all together as we have done further up here, and found that when you add together the mass of glucose, you end up with 72, 12, and 96. Add them together, and you know every 1 glucose is 180 AMUs. So you know every 1 mole of glucose is 180 AMUs or grams. So again, looking at a unit and value equaling another unit value is a conversion factor, just like grams to kilograms, centimeters to inches. It is no different. These 1 mole of carbon is 12 AMUs or grams, or 1 mole of glucose is 180 AMUs, or grams is simply a conversion factor, and we can use dimensional analysis to convert between grams or AMUs and moles. Now, of course, grams are a lot more practical because that's what is used in lab, not so much AMUs, and we do go back and forth between grams and moles all the time, so it's important to know how to convert between them. Let's take a look at a couple of examples here. How many moles are in 144 grams of glucose? Well, they give you the formula, so of course you would find the molecular weight, which is the equivalent of 1 mole. So this would be your go-to conversion factor. Now, you're going to have to basically calculate your conversion factor every single time for every problem, because every compound and every element is going to have a different conversion factor, a different atomic or molecular weight for that 1 mole. It's not like just looking up the fact that 1 inch is always 2.54 centimeters. It's not, you don't look them up and they're not the same for all the time, but rather they vary and they're individualized. So you have to determine the conversion factor that applies to each compound for each particular problem. So luckily here we already know what the conversion factor for glucose is, and we can go ahead and solve the problem. Again, you're at the given unit, 144 grams. We're converting 144 grams to moles. So write your given unit times your conversion factor. 1 mole of glucose is equivalent to 180 grams. Grams will be on the bottom of the fraction, so it lines up with the 144 grams, and the grams cancel out, leaving us with, of course, just moles. Multiply everything on the top, divide by the bottom, and 144 times 1 divided by 180 is 0.80 moles of glucose. So, very simple gram to mole conversion. Let's go backwards now and go from moles to grams. How many grams of sodium hydroxide are present in 3.45 moles of sodium hydroxide? All right, and again, what we're going to be looking for here, first and foremost, is our conversion factor. So we want to know, in 1 mole, because it's always 1 mole equals how many grams, in 1 mole of NaOH, how many grams do we have? Well, we're going to take the mass of sodium, which is 23 from the periodic table, the mass of oxygen, which is 16, and the mass of hydrogen, which is 1, and add them together. So 23 plus 16 plus 1 is 40 grams. So 1 mole of sodium hydroxide actually weighs 40 grams. That's our conversion factor. Let's now go here and solve the problem. Again, write your given unit. So we're asked how many grams are present in 3.45 moles. 3.45 moles of NaOH times our conversion factor, where every 1 mole of NaOH is equivalent to 40 grams of NaOH. Moles and moles, of course, again line up and are eliminated. 3.45 times 40 divided by 1 is 138. Only unit left, of course, is grams of NaOH, and that's exactly what we were asked to solve for. So the equivalent of 3.45 moles of sodium hydroxide is actually 138 grams. Now, in the next section, we're going to look and see how we can convert moles to molecules and atoms, and there will be an additional video tutorial for that.